Welcome to my YouTube channel. Today we are going to look at Neco 2024 objective questions. So I'm going to be looking at the calculation part. Please watch this video to the end so that I can understand how you can attempt problems in external exams. Stay tuned. Neco 2024 number 3 question. A car traveled with a constant velocity of 10 meters per second for 15 seconds. Calculate the distance covered within this period. For us to solve this, we are going to state our parameters. Solution. We are given the velocity, which is also the same thing as the speed, as 10 meters per second. We are given the time, which is 15 seconds. We are asked to calculate the distance. Distance is what? X. There is a relationship between distance and velocity. Velocity is equals to distance all over what? Time. So let's substitute our values. We have velocity as 10. We have 10 is equals to distance is unknown all over time, which is what? 15. Because we are looking for the distance, I will say this 10 is over what? 1. I say cross multiply. I want to make this the subject. X times 1 is what? X is equals to 10 times 5 is what? I have 10 times 15 is what? I have 10 times what? 15. So x, which is the distance, is going to give me what? 150 meters. So the distance covered within this period is 150 meters. Let's look at question number 4. The diagram illustrates the velocity time graph of the motion of a body. Calculate the magnitude of its deceleration. Now, if you are asked to find deceleration is from here to here. But before I solve, I'm going to label it A, B, C, D, and E. Acceleration is when the velocity of a body increases with time, while deceleration is when the velocity of a body decreases with what? Time. So from here to here, the velocity of the body increases. So this is acceleration. And the area covered by this can help us to get our acceleration. While deceleration, this body decreases with what? Time. And the area covered by this can help us to get our deceleration. But from this particular question, we are asked to get the deceleration. So you are looking for this triangle. Let me bring it out. We have this. So this is B, D, and what? C. And deceleration is change in velocity over change in what? Time. This is change in V, while this is change in what? T. Okay? So for us to get it, we are going to say difference between B and D. That is what? BD all over what? Because it's a negative of acceleration, I'm going to go opposite of what I have, which is supposed to be what? DC. I hope you understand. Now, if I am asked to take my B, I will go to the vertical axis, going outside here to see what I have. So B on the vertical is what? 20, and D on the vertical is what? 0. So going by that, I will have what? 20 minus what? 0 divided by. Now come to the time. I will have DC. D on the horizontal is 15, while C on the horizontal is what? 18. So I will have now 15 minus what? 18. Because this is deceleration, it is a negative of what? Acceleration. So the negative sign is going to come from the horizontal axis, which is the time. So I'll have A is equals to 20 minus 0 is going to give me what? 20 divided by 15 minus 18 is going to give me what? Minus what? 3. I now have the negative sign. So I'm going to divide. 20 divided by 3 is going to give me minus 6.67 approximately meters per second square. So therefore, deceleration of the body or the board is equals to minus 6.67 meters per second square. Let's look at question number 6. A body starts from rest and move with a uniform acceleration a until it attains a velocity v. The expression for the time taken to attain this velocity in terms of the given parameters is dash. So we are given all these parameters for us to find the time, okay, but in terms of velocity. If a body starts from rest, automatically it means that u is equals to what? 0. And it move with a uniform acceleration, okay. So we are given what? A. Now it attains a velocity v. We have final what? Velocity. We are asked to find the what? The time. Okay. Looking at the expressions we have, or the parameters we have, we are going to look at the first equations of motion. Let's see whether it's going to work out with what we have. It says that v is equals to u plus at. So all the parameters we need are provided in this equation 1, in this first equation of motion. So knowing that u is equals to 0, which is initial velocity, and also because the body starts from rest, so I'm going to replace this u with 0. So we have v is equals to 0 plus 80, which will give us v is equals to 80. And we are asked to find our time in terms of v. So we are going to make this time the subject by dividing both sides by a, which is our acceleration. We divide both sides by what? A. It will cancel. So my t is equals to v over a. So this is my time with respect to what? Velocity and acceleration. I hope you understand that. So let's look at this question number 7. A force of 150 Newton is applied perpendicularly to the end of a 30 centimeter spanner to remove a knot. Calculate the moment of the force. So pay attention. For us to get the moment, let us take the parameters. Solution. We are given the force, which is 150 Newton. We are given the distance, which is 30 centimeters. And distance is meant to be in meters. So we are going to divide by what? By 100. If we divide by 100, this cancel this. I'm going to be left with what? 0.3 what? Meters. So before I solve, I want to do a small illustration to show you how this force is being inclined perpendicularly. This is the force. Why this is what? The perpendicular what? Distance. So in this place, the distance which we have converted is given as 0.3 what? Meters. While the force is given as what? 150 what? Newton. For us to get the moment is equals to force times perpendicular distance. Force times perpendicular distance. And the force given is 150 times the distance, which is perpendicular distance from the center to the force, is 0.3. By the time you multiply, this can cancel this, so I'm left with 15 times 3 to give me what? 45. So the moment is 45 Newton meters. I hope you understand that. Question 9 says, a ball kicked at an angle 40 degrees to the horizontal, hits the ground 3 seconds later. Calculate the initial velocity of the ball, neglecting air resistance. And we are given acceleration due to gravity g equals 10 meters per second square. Looking at this question, we are looking at projectile, and we are given the time, which is the time of what? Flight. So let us take the parameters given. Theta is given as 40 degrees, then the time of flight, which is t, is given as 3 seconds. We are asked to find our initial velocity, which is what we are looking for, and we are given acceleration due to gravity as 10 meters per second square. So looking at this question, we are going to use the equation or the formula for time of flight, which is t is equals to 2u sine theta over what? G. Since we are looking for u, let us substitute the values we have. Our time is given as 3. 3 over 1 is equals to 2u sine what? 40 divided by 10. So I will do cross multiply. 3 times 10 is going to give me 30. So I will have u sine 40 is equals to what? 30. Okay? So I will say 2u. Let me find out what is sine 40. Sine 40 is equals to 0.6428 is equals to 30. I divide both sides by this to give me, divided by 0.6428. 0.6428. So I have 2u is equals to 30 divided by 0.6428. It's going to give me 46.67. Then I'm going to divide both sides by what? By 2. 2 cancel 2, which is my initial velocity, divided by it is going to give me 23.34 approximately meters per second. Please, if you are watching this video for the first time, please do well to subscribe to my channel, give it a thumbs up, comment and share. Stay tuned.